Okay, today's July 4th. Right now, I'm going to demonstrate the charging BMS. This is going really well right now. This is for one cell. For three cells, it's going to be easy. Within that, I will be providing a more varying at 12 volts with some amperage coming through to properly charge it. But what I have so far, this is particularly 90% focused on the one cell. So I have the battery output here. This might look very intimidating. This ESP32 is nothing, so just ignore what's the ESP32. I'm normally feeding about 650 milliamps through here. This is a whole, and this will be individual for each. Well, this will be in the beginning with the big heat sinks, because these were already heating up when I tested it for about 12 volts. It was jumping like to 500 milliamps. And it was going a little up, and I should have just incremented. But these help a lot. These two help a lot for inputting. Let me start from the beginning, sorry. So let's say hypothetically, not hypothetically, to properly measure the actual, these are diodes. These are 1N4007, conventional diodes. Of course, they're going to have a 0.7 voltage measuring, of course. This is a notification LED, indicate that it's fully charged, which I haven't really fully tested that yet, but I wanted to just demonstrate the whole shebang here. So right here, this little transistor looking thing is a Zener diode kind of, it's not exactly, but it has an anode, cathode, and as a reference. That reference is directly tied towards this variable potentiometer. You can also mention it's a trimmer. It's potato. I'm not fully sure. The difference, what I can confidently say, is most likely the feasibility of like incrementing it, like the specific way, I would assume. I'm not fully sure. I looked online, people were mentioning trimmer. I'm just like, okay. But this is a common node here for all ground. This is a common node here, this and this. I can't tie this because it isn't fitting too much. For a positive, these red wires. Within this connects, right here is the little transistor thing you might think is whatever, but it's a, sorry, this TL431 is the variable, and this is a TIP30C, which is a PNP transistor. It's a doped P. It's a kind of like an inverse of a N transistor, N-type transistor. Where the emitter is on the far left is the emitter is in pin 3, the collector, no, the emitter is in pin 3, yeah. In a PNP, the emitter is going to be on pin 3, but if it was an NPN, it would be, the collector would be on pin 3. That's the model I remember. Then this right here is the TL431, the Zener diode I was mentioning. Voltage divider, 20 kilo ohm, 1 kilo ohm pull up for the transistor PNP. You would have a 1 kilo ohm pull up, some manner. I mean, these are filtering capacitors here. These are 100 microfarad. This is a LM317 right here. This is for current management, because LM317 is very variable. You can easily do, let me just, I'm going to set this up here before I leave here. We have 9 volts. You do, without that, what I'm about to demonstrate, you do not want to test it with 9 volts because it's not regulated. The LM317 is regulated, but I'm not testing with that right now. No, it's too much. It's too much. I don't know if y'all can see. There you go. We have no load supplied, of course. And you're going to see a relation towards that. So right now I'm disconnecting the process here and then connect it right here. Let's connect the battery. And am I doing that right? I think I am. Oh shit, what the fuck? Sorry, I'm gonna cut that. I ain't getting no. Oh, my dumbass, it's not even plugged in. There you go. Now it's pulling 20 milliamps, whatever. There's a small load here. What I mean load, the resistance. So, well, no, there's a big resistance. So if we do like here, or I think I could read it up there. Whatever. I know what I'm talking about here. I need to most likely put it right here. Okay, this is where we're getting here. With this, we have this variable potentiometer reference. We can then adjust accordingly. Lower, all the way, that's the lowest it can go. Yep, lowest. And then the highest is, of course, is going to be the limit. Of course, we're getting brilliant. Okay. No, you don't want that. You don't want that. I'm going to, for the maximum charging for a lithium ion battery, any really ion or lithium battery is going to be 4.2 volts. But within full charge. Nominally, there's going to be 3.7 to 4. With that, you don't want to start going too crazy with it because you're going to risk overcharging, which, I mean, again, you have robustness in the ICs and stuff, but again, for my sake of mind, I don't want to risk that, especially what I'm doing here. Yeah, I already mentioned that. Alrighty, 317, 3M set 317. This is the current monitor version. All it is, since we know the voltage reference for it, it demonstrates. Let me disconnect this. Let me connect it right back. As you see, I disconnected it. Of course, we're not going to get a load. But you see when I connect it to the pin 2, which is the input, hey, we're still getting no voltage now. Why is that? Because these are clamped. There's a specific limit for it that's stated. So we only want, when we sense, when LM317 senses or gets whatever input is coming through, it limits it and then opens a path towards this whole thing once it receives a certain variable load. So at 1.25 volts, internally the reference is divided by 2 ohms, which I have right here. 1 ohm tied to another ohm, 2 ohms, 1 plus 1 is 2. Do that, you get 625 milliamps, I mentioned that earlier. Filter and capacitor. Then after that, you connect here, our voltage regulator. All it is just a voltage divider. I have a 1.3 kilo ohm. R1, R2 is about, well, this is a 36 kilo ohm, 10 kilo ohm, and then a 4.7 kilo ohm. Tied in parallel, varying current, excuse me. And with that, it gets you about 2.94 kilo ohms, or 2.9 to 2.94 kilo ohms. Within that, you do a voltage divider, and you get an output about 4.0, 4.1, max 4.1. With that, then we can see, okay, why is it split? I'm not fully sure why, but I know this works. Did a few tests on it, probably like 8 or 9 tests. Okay, now let's see. My battery's not connected, so let me turn everything off. And I should demonstrate how, like, putting the battery specifically, because you might say, oh yeah, we can easily plug and play. No. If I did not, like I mentioned before, did not have a properly regulated rail for this, did I do that? Yeah, you know what, I'm just gonna do this. There you go. Yes, reading the battery value. Goddamn. And 2, yeah. Okay, that's the battery varying value. That is the battery's feeding here. But with here, okay, everything's clamped. If I want to also mention, if I did not connect that to the voltage regulator, I would have a short circuit. Not a short circuit, well, like the current will come up and short everything. But now, since I have these LM317 to actually monitor and regulate, that actually clamps. And then, okay, let's see what's the value we can start doing. Okay. There you go. About 6 or 7. Okay. Well, not too fast. Not too fast now. Not too fast. Okay, I'm sorry. I'm joking. So we're getting. Let's see. We need to climb up a little more. It's gonna climb up. Yeah. Let me not stretch it that far. So right now it should be clamping down. Yeah. There you go. Yeah. So now it's clamping down at like 4.9. Well, it should be. Why is it climbing? No. There you go. There you go. But now it's at 9.16 volts. It's clamping down. It's like going up and going back down. That's good. Meaning that the limit is there for balancing and stuff. As you saw before. But we're getting about 190 milliamps. That's not fully enough for exactly it, but it demonstrated it works. The limit works. I need to fix this LED because this LED should be going on when it's whatever. But why is it? That's not good. Why is it climbing up? Okay. It's climbing up too much. It's climbing up too much. Whoa. That's not. That didn't count for that. Yeah, there's some little finkies, but again, I want to get mentioned. I only had literally today to do it, and I like built in like an hour. Okay. So at about 9 volts, it was kind of being finicky. Make sure nothing. Yeah, just in case. Okay. Now we're getting about 3.7. We're getting actually a good amount, which to be honest, I'm going to increase it a little more. I know I just decreased it, but so 8 volts. Battery is not reaching so much as that. It's being limited, of course. Let's do 8.5. Whatever it is. This is for one cell feeding in towards, so we should be feeding. If we feed like, I'm going to test this real quick. This is first time testing this right now, so I'm putting it. Let me see. It's going about. Let me push it about 10 volts and see what happens. Oh, that is not good. No, I should not be reaching. No, I should not be reaching that. No. I need to fix that because that is not okay. It's going way above than I actually should. So right now it's really performing really well. I really hope I was okay. I really hope I was showing you the whole thing. Okay, so at 8 volts it's performing really well. I need to fix that issue when it goes above. The current is not spiking as much as you would anticipate, but like 160 milliamps, it's not bad for 8 volts. But I do need to fix that issue. I don't know why it's not clamping properly. These are not getting that hot, which is kind of really concerning me. But yeah, this is kind of, let me let it settle. Yeah. So, okay, we're getting a good. Okay, that's good. So 8.2, it's fine. Yeah. Alrighty. Well, that's it. And I did the math over there for the max voltage. Make sure. Yeah, okay, it's good. For actually the voltage output expected, which is 4.04, I should expect from the LM17 to nominally balance, which it kind of was. Well, no, it wasn't. It was spiking. As soon as I was reaching 10 to 12 volts on there, the current was being limited perfectly. The voltage was being iffy, very, very iffy, where it was spiking to 4, as you saw, 4.3 to 4.4. That is not what we want at all. And that's something I need to fix right there. Now let's check up on this. Yeah, we're getting a good. After settling and stuff, I just need to put on a PCB. Well, first, regulate the actual increase and stuff. So we're getting, yeah, it's lowering. It's lowering. I feel like what it probably is, when professors watching this or something, I feel like what it is actually the spike happening. It's increasing, but it will decrease. I need a fully, you know what, let's test it again. So we're getting about 250 milliamps. It's about 9 volts. Okay. Okay. No, 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 no. Why are you doing this to me? Okay, at 9 volts is doing good. No, why is it spiking? Gosh. Oh no, never mind, that's fine. That's what it was. This wasn't fully connected down. Okay. That makes sense now. It wasn't fully connected down. That's the reason why. Okay, that makes sense. Alrighty. Sorry for all that. But there you go. We're actually getting a nominal perfect. 4 volts, 9 volt, perfect. Then this moves to stage 2 and stuff.